All right, this is part 4 of section 5.1. We're going to write an equation for this graph right here. So we already know from the last videos that x squared starts about here, starts at the origin. Now this one is going the opposite direction, so we know that we're going to have a negative in front, and it's also moved, looks like 2 units to the left. So it'll be x plus 2, and then it is moved 1, 2, 3 units up. Now we need to figure out if there has been any stretching or compression with this particular graph. So what I'm going to do is, this is probably the easiest way, is we're going to put an A in front of this, the parentheses, and that's because that's where it would indicate if we have stretching or compression. And we're going to pick a nice point off this graph and plug it into what we have here and see what the value of A would be. So it looks like a nice point would be right here, and that is 2, -1. Okay, so y is -1, negative A, x is 2, and then we're just going to solve for A. Okay, so that would be -1, negative A. 4 times 4 is 16, plus 3. Subtract 3 from both sides, so we have -4 equals negative A 16. So we're going to have -4 divided by -16. So cancel the 16s and the negatives. So then we got a negative divided by a negative. Those will cancel out, become positive. Take a 4 out here. Take a 4 out here. So it looks like A is equal to 1/4. Okay, so what we need to do is go back, get rid of all this, and need to replace A with negative, or A with 1/4. So we'll have -1/4 x plus 2 squared plus 3. So then this will be your equation for this graph. Now going back here, I did use t-tables, which you don't necessarily have to use. All you have to do is figure out, did it shift to the left, did it go up or down? And then what you can do is you can pick a nice point on the graph. So say right here, that looks like that is 4, 1. And then place an A right in front of it just to see if there's any type of stretching or compression that's going in. Plug in those values. So this is 1, this is 4. This should come out to be 1. Okay, so this would be 2 squared minus 3. So this would be 4 minus 3, add a 3. So, yep, it comes out to be 1. Divide by 4 on both sides. So A is 1. So in this case, you don't have any stretching or compression. In this one over here, this one right here, we had, let's see, we had already plugged in the points, and it should be negative A. Not sure I finished this one. It should be A plus 2, subtract 2 from both sides, so -3 equals negative A. So that means divide by a -1, just to get rid of the negatives, or to get rid of the negative for negative A. So it looks like A is equal to 3 for this one. So we'll get rid of all this. Okay, so our final answer for this one is -3x plus 1 squared plus 2. So that's really all you need to do is to figure out, did it shift to the left or to the right, did it go up or down, and then you can pick a nice point on the graph, plug that in to this the function that you already have and stick an a in front of the parentheses and solve for a, and then whatever a is, if it's 1, you don't have to put a 1. But if it's 3 or 1/4, put that in front of the parentheses, and that will be your stretch factor or your stretching or compressing. That'd be your compression factor. Okay, now let's look at this one. Okay, so the height y in feet of a ball thrown by a child is y equals -3x squared plus 5x plus 2, where x is a horizontal distance in feet from the point at which the ball was thrown. Okay, so, and you know what y is? Y is the height, and x is the horizontal distance. So it says how high, or basically, what is y, is the ball when it leaves the child's hand. Okay, so the child is holding this toy, and it hasn't thrown it into the air yet. So it hasn't gone anywhere. So that means the horizontal distance would be 0. Okay, so what we need to do is y is equal to, and wherever I see an x value, I'm going to replace that with 0. So this term goes to 0. This term goes to 0, and I'm left with 2. Okay, so that means that y is equal to 2 feet. What is the maximum height of the ball? Okay, the maximum height, or if we're talking about, we have a function that is a quadratic. We're looking for the maximum. The only way to find the maximum or minimum within a quadratic is to find the vertex. So we need to find the vertex of this quadratic. So we need to identify our a and our b, -3 and 5. H will be -b over 2a, so -5 over 2 times -3. Negatives will go away, so I have 5 over 6. Okay, I need to find my k, which is inserting the 5 over 6 into my function. So -3, 5 over 6 squared, plus 5 times 5 over 6 plus 2. Okay, so this is going to be -3 times 25 over 36 plus 25 over 6 plus 2. Looks like I can take a 3 out here, left with 1. Take a 3 out here, and I'm left with 12. So I have -25 over 12 plus 25 over 6. And I'm going to multiply that 2 over 2 plus 2 over 1, and I'm going to multiply that 12 over 12. Okay, so let me move some of my information here. Okay, so we've got -25 over 12 plus 50 over 12 plus 24 over 12. So -25 plus 50 plus 24. Okay, 50 minus 25 is 25. So I've got 25 plus 24 over 12. So that would be 49 over 12. Okay, so vertex would be, let's see, 5 over 6 is what we got for h, and then we just found 49 over 12 for our k value. Now notice this is the 5 over 6 is in the x-coordinate spot, and the 49 over 12 is in the y-coordinate spot. So when it says what is the maximum height of the ball, and we know that this is a maximum because the number right in front of x squared is a -3, and if it's a negative, then we have a parabola that is opening downwards like this. So here's our vertex, which means it's going to be a maximum. Okay, so the maximum height of the ball is 49 over 12 feet. Last question is how far from the child does the ball strike the ground? Round your final answer to 2 decimal places. Okay, so the ball, when the ball, it says strikes the ground, then what we're talking about is there's absolutely no height to the ball because it's on the ground. So the height would be 0, which means y would be 0. Okay, so we're looking for how far from the child, or the horizontal distance, which we know is x. So we're going to let 0 be y, and then we're going to solve for x. Okay, so I'm going to factor out a negative first. Okay, so I'm going to actually first write it without that leading coefficient, and then multiply the leading coefficient with this over here. So that's going to give me negative 6. Then I'm going to factor that. So x here, looks like I can break this up into 3 and 2. Okay, that won't work because we need one negative and one positive to make this a negative 6. So those won't work. So let's try 6 and 1. Okay, so 1 times negative 6 gives us negative 6. And then a negative 6 plus 1 gives us negative 5, so that works. Okay, so then we have, so when we divided out or left out this 3, we're going to put it back now. 1 over 3, x minus 6 over 3. Okay, for this one, I'm going to move the 3 to the front of x plus 1. And actually, we don't have to do that step since we are trying to solve for x. Okay, so we got two things multiplied together, and we could clean that up just a hair. This would be 2. Okay, so then we've got two things multiplied together equal to 0. So I can set both of those equal to 0. Okay, so divide both sides by this negative 1. That'll still be 0. Move that 1/3 over. So x is equal to negative 1/3, and I'll move this over here. So x is equal to negative 1/3, and then add 2 to both sides. X is equal to 2. Okay, now it's talking about how far from the child does the ball strike the ground. We got two answers. We got x is equal to 2, and we got x is equal to negative 1/3. Now for distance, it doesn't make sense for it to be negative, so this can't be the answer. So the only answer that we have is x is equal to 2 feet. So it goes 2 feet from the child when it strikes the ground.